Okay, so we're going to go back and pick up where we left off some time ago, back in, I think it was module 2 or 3, where we dealt with some of Christian Garvin's works. And he had the 3 tutorials that we dealt with, the first 2 on the primers on data science and Python, and then stats was the third. And then his 4th tutorial is on machine learning and data science. So there's a link in the Module 7 resources that take you to this notebook, as well as you can run up in hierarchy to everything for his IEEE conference. And essentially what we're doing is, there's a lot of stuff that we've already done. It's just, here's Christians provided a notebook to walk through and get an understanding. So essentially, first part, we're going to load and inspect the data. Something we've already seen, already done. Look at the shape, which columns do we have available to us, or the features, and what the form that they're in is. And then from there, let's go ahead and describe the different features. The descriptive statistics, mean, standard deviations, the min, the quartiles, the max. So now we've got those descriptive statistics. We'll look at the info about the data frame as a whole. Data types for each column. We got any non-nulls. There's 768 records. Every one of the records has data associated with each of the features. So we see what's there. We can go through and look at, we need to come up with some kind of prediction. How are we going to classify what we're looking to do? In some instances, a data set may be imbalanced. Now, here's an example. Let's say if I want to train a model to be able to distinguish or classify images as dogs or cats. And there were 10,000 images. And 9,950 of the images were of dogs. 50 of them were cats. It's not a very balanced data set, and we're going to run into problems. Okay, so that's an issue we need to think about. How balanced are things? What accuracy rate are we expecting? Is it going to be impacted by an imbalance? We need to go through, and many times we may programmatically separate the features from the labels. And we'll do a train test split. So we've seen that in the past using train test split function that'll break it up into X train, X test, Y train, Y test. Features, label. Features, label. Okay. So let me reword that. So the training, we've got features for training and label for training, test for training, test for features, and test for labels. And we go through and we split it up, and on this it's a 75-25 split. They've got a randomizer going on, and it goes through and it breaks it up and say, all right, what are we dealing with? And male to female, or however it may be, zeros to ones, zeros to ones. they are representative. Training and test. It looks good. It may not be balanced zeros to ones, but the training and the test are representative of each other. So we're not looking too bad. And we'll come up with a model. So we've got what model are we going to start out with? It's all right. We'll go from scikit-learn, use a linear model. And it's a linear, or I should say on this one, it's a linear model using logistic regression. We're going to have it go through a maximum of 200 iterations to learn. There's a randomizer. We pass it the training set, features, and labels. It'll go through and fit those to the model. And then we'll go ahead and so let's go run it. Go learn. Let me say, what's the prediction? So our LRC is our model, logistic regression model. And we say, based on X test, give us some predictions. Okay. So here's the features, here's the labels. It predicted, we passed the prediction and what they should have been, and it'll tell us how accurate was it. It was 70, almost 73% accuracy. Is that good enough? We need to understand the different types of mistakes that models make. We've got 4 different categories that they fall in. True negatives. Predicted that it was negative, and it was in fact negative. So, or you predicted not diabetic, and in fact it is not diabetic in this example. False negatives. You said it wasn't diabetic, but in fact it was. False positive. You said it was diabetic, but it wasn't. And then there's true positive. You said it was diabetic, and in fact it was diabetic. So you're going to fall into one of these 4 different quadrants. When we run the model, we'll come up with values. So if I have a specific number that I'm feeding into, test it, it's going to come up with, each one will be in one of the 4. All right. From there, we start finding out how good is our model. And we need to understand what's important. If this is cancer diagnosis, how bad is it if I tell somebody they've got cancer when they don't? Or let's look at the flip side. How bad is it when they've got it and I tell them they don't? So it's false positives, false negatives. They're a big deal. So we've got types of errors. False positive is type 1 error. False negative is a type 2 error. And we've got little descriptions here on each of these. This notebook's going to be a great resource for you. So we've got metrics when we run a classification report. Pass it, Y test, so it's the known labels and what we've predicted. This will give us a classification report. And this tells us precision, recall, the F1 score, and support. When we look at it, precision, it penalizes false positives. So out of all the instances predicted to be of certain class, what function is actually from that class? True positive divided by, so the calculation itself is true positive divided by true positive plus false positive. So we've got the math to go ahead and do it for each of them. Okay. Recall, so here's our precision. Recall is when we go through and the calculation is true positive divided by true positive plus false negative. So here's our recall. the F1 score, it essentially combines precision and recall into one number. When we look at it, if this one's 77 and this one's 84, F1 scores come right there in between it. 64 and 52, kind of right in between it. So F1 scores kind of like they take the two of them, and I don't want to say it's the average, but take the two of them and they come up with that number. All right. From there, all right, are there other classifiers that we could choose to see, can we get better numbers? What can we do to get better numbers? We go use a decision tree classifier. Let's go do the same thing with that. All right, here's our numbers. F1 score of 81 and 60. Back here we were 80 and 57. Okay, we're getting better. Fine-tune the classifier. Now, I've talked about hyperparameters before, and I compared it to, like, if you're going to cook something in an air fryer, well, how long do you put it in there? How hot is it? Do you turn the fan on? All the little switches and changes that you can make. So what we can do is to change different parameters along the way. So let's say we've got a decision tree classifier. We've got some values here that we can change. We've got the criteria, we talk about Gini or entropy, how we're going to split best, random, max depth. So there's different things we can go modify there. It goes through and it runs it. And how do we turn out now? 88 and 74. We're getting better. We're getting better doing a grid search. So he's got summary to go through and wrap everything up, but it's a good example of how to go through and use machine learning to identify, choosing from different models to predict whether somebody's diabetic or not. Okay. So with that said, we may have another video after this. I'm not sure. This one should be number 3 in module 7.